That's the cause, and in this video we'll be looking at the lead accumulator, which is an example of a secondary cell. In the previous video we looked at the primary cell, the Daniel and the Leclanche cell. So this video will be devoted to peeping into the mechanism of the lead accumulator, normally called car batteries. So you can draw this diagram in your notes. For diagram of lead accumulator, the electrodes are made of lead and lead-2 oxide, and then the electrolyte is made of dilute H2SO4. Like we said before, that lead accumulator is a secondary cell. You can also call it a storage cell. They are mostly used in car batteries, and they run down after some times. So to recharge them, you pass direct current through them. When you have a fully charged accumulator, what happens during the discharging of the lead battery, of the lead accumulator? First and foremost, know that the cathode of the lead accumulator is lead-4 oxide. Lead-4 oxide is PbO2. That's the cathode of the lead accumulator, lead-4 oxide, PbO2. The anode is a metallic lead. So this is the anode, metallic lead. This is the cathode, which is made of lead-4 oxide. Don't forget that in electrochemical cell, the positive electrode is the cathode, the negative one is the anode. So the anode is a lead rod. And then, like I told you before, the electrolyte is dilute H2SO4. The cell usually gets discharged when you connect it to an external circuit. Say, for connect it to a phone, connect it to a vehicle, connect it to a laptop. So the cell or the battery will start getting discharged. What happens during the discharging process? What happens? Now, what happens is that the anode, which is the producer of electrons, you know that anode produces electron. So the lead anode loses 2 electrons, as you can see from the movement of the electron here. So the lead anode, which is the negative side, loses 2 electrons to become lead-2 ion. That's the equation for the loss of electron in lead anode. So the lead-2 ion now combine with the SO42 minus that is inside the battery. Don't forget that the electrolyte is dilute H2SO4. So there is SO24 minus in the electrolyte. There is H plus also in the electrolyte. So when the lead-2 ion is formed from the metallic lead, the lead-2 ion combine with sulfate ion to give us an insoluble lead-2 sulfate, which is PbSO4. The impact name is lead-2 tetraoxosulfate 6 salt. So that salt is insoluble, and because it is insoluble, it gets deposited on the anode. So it covers the anode as time goes on. As you can see in this place, try and look at the second diagram very well, the second structure very well. You will see where the sulfate ion goes to the lead to form sulfate, to form PbSO4. Good. So that's what happens at the anode. The lead loses 2 electrons to become lead-2 plus, and because there is SO24 minus in the solution, the lead-2 plus combine with it to form an insoluble lead-2 tetraoxosulfate 6 salt that covers or coats the lead rod. So the electron that was produced at the anode will travel to the cathode. At the cathode, the lead-2 oxide, the lead-4 oxide, which is the cathode, will receive the electron and get reduced to lead-2 ion. Don't forget that at the anode, the metallic lead loses electron and gets oxidized. Anode is a site of oxidation. So it get oxidized to lead 2 ion. But here the electron coming from the anode is accepted by the lead 4 oxide, and when you gain electron, that's reduction. So lead 4 oxide reduces to lead 2 ion. Have you seen that now? So when you balance the equation in acidic medium, you get this equation. So because lead 2 ion is also formed, it will also combine with the SO2 minus in the electrolyte and get deposited as a solid, or if you like, as an insoluble salt on the cathode. So don't forget now, white substance is covering the anode already. Another white substance is now covering the cathode. So this is what will happen as the discharging process continue to take place. As you can see in this diagram now, you can see the whitish material here. That's the lead sulfate covering the surface of the electrode. Look at the cathode also, PbO2. You can see the white lead sulfate covering the anode and the cathode. So as the electrode completely become covered with the white deposit of the lead 2 tetraphase salt, the lead accumulator will stop producing current, because once you cover the electrode with that material, the electrode will no longer be able to interact with the electrolyte. So the process will stop. That means it has become fully discharged. So that's what happens when your phone is reading 100%, 90%, 80%, 70%, 10%, 5%, 1%. That is the amount of the the electrode remaining to be covered. So once it is fully covered with lead sulfate, then the battery will stop working, and you have to make it start working again by recharging it. So that is how you can make it to start working again. Now during the discharging process, two things happens. Number one, the density of the acid will decrease from 1.25 to 1.15 gram per cm cube. Now it is very normal that the density should decrease, because the acid, the SO2 minus and the H plus in the the SO2 minus has been reacted with by lead. So that sulfate ion, some of them have left the solution to form the white deposit of PbSO4. So that white deposit is also obtained from the electrolyte. So the density will reduce, because the SO2 minus is no longer present in the electrolyte in the amount that it was before. So there will be reduction in the density of the electrolyte, and the EMF of the cell will drop from 2.2 voltage to 1.8 voltage. So those two things happens during the discharging process. Now when your battery has fully discharged, you have to plug it. You have to plug the battery to a source of external supply of current or electricity that will recharge the battery. If it's your phone, if it's your laptop, if it's your rechargeable wristwatch, once it goes down, you have to plug it to an external source of voltage that will help us to recharge that battery. So what now happens during the recharging of battery? During recharging of battery, the anode of the charger will be connected to the cathode of the battery. As you can see in this place, the anode of the charger will be connected to the cathode of the battery, whereas the cathode of the charger, this is the battery charger now, the cathode will be connected to the anode to the anode of the battery. Let's take note of that. So that is how you charge a lead accumulator, by connecting it to an external supply of current. So because of that, the anode of the charged cell becomes the cathode when you are recharging it, and then the cathode of the charged cell now becomes the anode when you are reversing when you are recharging it. So the reverse of what happens during the discharging process will also happen during the recharging process. Okay, so at the anode and the cathode of both of them, the white deposit of PbSO4 is first ionized back into lead-2 ion and SO2 minus. So the reverse of what happened in discharging is what will now happen during recharging. In discharging, lead combine with SO2 minus to form PbSO4 solid. But when you are now recharging, when you connect it to an external charger, the current will help to force the PbSO4 to become ionized back. So what happens is that the Pb2 plus and SO2 minus, the SO2 minus, not plus, the PbSO4 and the sulfate ion will be, separated from that PbSO4. So then at the cathode side, the Pb2 plus will be, reduced to metallic lead. Then that Pb2 plus of the anode will now be oxidized again to lead-4 oxide. That was what we had before the discharging started taking place. Okay, so these are the equations at the anode and cathode. First and foremost, what happened? The current will force the PbSO4 solid to ionize into lead-2 ion and SO2 minus. So the SO2 minus will go back into solution, whereas the lead-2 plus, because it is now at the cathode, become reduced to ordinary lead. Can you see that now? Lead that was our anode before. So that is what happens. Then at the anode of the recharging cell, which was the former cathode of the discharging cell. So now it has become the anode as you connect it to an external supply of current or of a voltage now. So the anode also, PbSO4 solid will break into lead-2 plus and SO2 minus. Then the lead-2 plus that is formed will now become oxidized into lead-4 oxide. So Pb2 plus here changes to PbO2, that's lead-4 oxide. So that's oxidation, increase in the oxidation number from +2 to +4. Then if you balance that equation in acidic medium, you will get this particular equation. So this is what happens during the recharging process. The reverse of what occurs in discharging is what will now occur during recharging. So you are forcing the reaction to go back. You are reversing the reaction by using an external supply of current. So during the recharging process, the EMF of the cell will return to 2.2 voltage. Then the density of the cell will also return to the original 1.25 voltage. So this is what happens during the discharging and the recharging of lead accumulator, commonly called the car batteries. So in my next video, which will be the final video on electrochemical cell, I'll be discussing the corrosion of metals, specifically rusting of iron as an electrochemical process. Then I'll be discussing how you can prevent rusting of iron by a method called sacrificial cathodic protection. So look forward to it. God bless you.